This is video 1 for the binomial theorem, and what we're going to learn here is we're going to learn a rule, that's what a theorem is, that allows us to expand easily problems involving binomials raised to powers. So for example, what you saw in class today when you worked with your groups is x plus y to the fourth power. With your group, you took this binomial, it has two terms, and raised it to the fourth power, okay, just by multiplying it out. You took x plus y times x plus y times x plus y times x plus y to the fourth power, and you did the distributive property a whole bunch of times. Were very careful with your work, combined like terms, and if your group was successful, you ended up with this expansion: x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. And it took a lot of work to do all that. So the idea of the binomial theorem is to use patterns that we see in these expansions to try to tackle more difficult problems, because there's an awful lot of patterns that exist here, and hopefully you see some of them right now. So first of all, I'm going to show you the binomial theorem as a formula. This is in your packet. It's a little scary looking. You're not responsible for memorizing this formula because I'm just going to walk you through the steps here, but I do want to make you aware of the formula and its pieces. The binomial theorem says if I want to expand this binomial raised to a power, I can follow this cookbook recipe. Now, there's a whole bunch of stuff here in this recipe you need to be aware of. First of all, this just says that every term will have a raised to some power. This means that every term will have b raised to some power. This guy right here, don't be scared off by him. That's just an alternate way of writing combinations. So, example 10c3 would just be 10, 3, that'd be 10c3. And the last piece here is this little guy here, that just means sum. It means add them all up. So every piece of this formula means to do something, but usually you're not going to use this formula to do these problems. I just wanted you to be aware of it, because on this next slide, here are the steps you're going to follow. Here's how we take that formula and now leverage it in the steps. So if we wanted to expand a plus b to the nth power, so here's a problem we want to do. We don't want to write it out n times and do the distributive property. We'd rather just use the patterns. There's really 4 steps to every problem. First step, there will be n plus 1 terms. So if your problem is to the 5th power, there'll be 6 terms. If your problem is to the 7th power, there'll be 8 terms. Okay? Next, every term will have a power of a, and they will decrease. Just like you saw before, you had x to the 4th power, then x cubed, then x squared, then x, and then no x whatsoever. And they'll start with n. Next, we'll have powers of b. They will increase starting at 0 every term. And then finally, every term will have a coefficient. And the coefficients can come from one of 2 places. Either they're combinations or they come from Pascal's triangle. Now you have a choice here, but what you should have seen in today's exploration is that Pascal's triangle, every number in Pascal's triangle is a combination. It's going to be most helpful if you have your Pascal's triangle handy to do these problems. It looks pretty intimidating, but I think when you see me go through the step-by-step process, you'll find it's actually pretty easy to do. So let's do 2 examples. Here's our first example. Let's say we wanted to do x plus y to the 5th power. Well, first thing we have to figure out is how many terms there's going to be. Since this is a 5th power problem, it means that there will be 6 terms. So what I'm going to start by doing is writing out 6 blanks to represent the 6 terms. Now one issue here is I'm using an iPad, so I have to go over 2 lines. This is really 1 line of work here. So I have 6 terms that I'm going to separate by plus signs, because this is all a sum. Okay? So first step is complete. We have 6 terms. Next thing is every term will have powers of x, and they will start with the 5th power. So I will have x to the 5th, x to the 4th, x cubed, I apologize for my nasty writing on this iPad, x squared, x to the 1st, and then x to the 0 power. Every term will also have powers of y, but instead of going 5, 4, 3, 2, 1, they'll go in the opposite direction. We'll start at y to the 0, then y to the 1st, it's looking messy, but that's okay, y squared, y cubed, y to the 4th, and y to the 5th. So the first 3 rules are already done, first 3 steps. Last step is that every term here is going to have a coefficient. Every term here is going to have some number in front. And those numbers come from Pascal's triangle. So what you need to look at here is, since this is a 5th power problem, go to your Pascal's triangle and you are looking for the 5th row. And that's the row that starts with 1, 5, and it has stuff after it. And if you find that row, you'll see that it is 1, 5, 10, 10, 5, 1. Okay? And that's pretty much it. The last step now is to take each of these individual terms, which are all multiplications, and simplify them if I can. Some of them can be, some of them can't be. Well, the first term is just x to the fifth. Everything else in that blank is worth 1. My next term is 5x to the fourth y. My next term is 10x cubed y squared, plus my next term is 10x squared y cubed, and then 5xy to the fourth. And finally, this term right here, this guy right here, 1 is worth 1, x to the 0 is worth 1. All that survives is y to the fifth. That's all I need to write. So notice, instead of taking x plus y to the fifth power and having to write it out 5 times, I can just use the patterns and figure out what it would expand to right here. Okay, so there's example 1. Here's example 2, x plus 2 to the fourth power. So let's go through it step by step. It will have 5 terms, because it is a fourth power problem. So I'm going to try to write out 5 terms here. 1, 2, 3, 4, 5. Again, hard to write on an iPad. Separated by plus signs. This is all a sum. Okay. Powers of x. I'll start with x to the fourth, x cubed, x squared, x to the first, x to the 0 power. Let me write this down here. X to the 0 power. Anything to the 0's power is worth 1. So do I really need to write x to the 0 power here? I don't think so. X to the 0 power is really just worth 1. So I'm just going to write a 1 here. It's easier. Okay. And again, I started with x to the fourth because this is a fourth power problem. Now next, I don't have a y. I have a 2 here. Well, it's going to behave the same way. You'll see how this works in the end. But I'm going to start with 2 to the 0 power, 2 to the first power, 2 squared, 2 cubed, 2 to the fourth. I'm going to write multiply here so I don't write the number 12. Okay? And finally, I need coefficients. Well, this is the fourth power, so I need the fourth row of Pascal's triangle. The fourth row is the one that starts 1, 4. And you'll find that row. It is 1, 4, 6, 4, and 1. So now your last job is to clean up each of these steps as best as you can. So let me use a different color here so you can see. This blank right here, well, 1 is worth 1. 2 to the 0 power is worth 1. The only thing that's worth anything here, really worth writing, is x to the fourth. Plus, this term right here, I have a 4 sitting here. I have 2 to the first. I know that's worth 2. If I multiply those, I have 8. So I have 8x cubed. Plus, this term right here, think about what I have, and I'm multiplying. I have a 6 right here, 2 squared right here. 6 times 2 squared, 6 times 4 is 24. So I have 24x squared. Okay. Plus, this blank right here. I have a 4 sitting here. I have 2 cubes sitting here. That's 4 times 8. That is 32. X to the first, just 32x. And finally on this blank, the only thing I have is 16. So my final expansion is x to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. It's a lot of steps. It is going to challenge your algebra ability and how you simplify things. You want to keep neat with your work, but I think you'll find it's a fairly easy way to simplify these guys.